Welcome to this lesson. So, in our today's lesson, we'll be talking about trigonometry. So, basically, trigonometry is a very simple and easy topic. So, the word trig just means triangle, and the nometry part just means the study. So, trigonometry is just the study of what triangles. Okay. So, what you are able to see there, it is just an overview of what we're going to be talking about. Yeah. So, we're going to start with the common ratios. What are common ratios? How do we evaluate common ratios? And then look, it's obvious. If we have something which is common, then we're also going to have what? Something which is uncommon. Okay. So from uncommon ratios, we're also going to talk about the evaluation of angles, that is angles from 0 degrees to 90 degrees, and angles that are from 90 degrees to 360 degrees. So these are two separate angles range 0 degrees to 90 degrees, and then the angles that are above 90 degrees but they are less than 360 degrees, how to evaluate them. Okay, so let us now go right into it. What are common ratios? Okay, so just from the name, common ratio, common ratio. So just as the name states, common ratio, these are basically very common. Yeah, I've been talking about the common ratios since grade 10, 11, 12, now in uni. So, common ratios. What are common ratios? So, basically, we have three common ratios. Number one, we have sine. Number two, we have cosine. And number three, we have tangent. Tangent, like that. So, these are the three common ratios that we have. And I think you guys now can remember, you can recall these same common ratios from grade 10, yeah, from secondary. That is how we were evaluating sine theta, how we were finding cos theta and tan theta, something like that. Something like that. Okay, so basically trigonometry is about triangle. So let us also have one triangle here. We see what we are going to be talking about. So let us have a triangle there. So that is a right angle triangle. The sides of a right angle triangle, those sides have got what? Names. Just according to the position of the side. So that one is referred to as opposite. So it is opposite in such a way that we are reading that angle in reference, rather, we are reading that side in reference to that angle. So that is the reason why we're terming that side as what? Opposite angle. So that is the opposite angle. And then this one, it is adjacent. So it is adjacent to this angle. So that is our angle of interest. Yeah, that's the reason why we call this as what? Adjacent. It is adjacent to that angle. And then this longest one, the longest side, we refer to it as what? An hypotenuse. Okay, so that is basically an hypotenuse. Hypotenuse. Okay. So now in secondary, we were finding sine theta, cos theta, and tan theta using what? Based on a certain mnemonic, which is a SOHCAHTOA. SOHCAHTOA. So even here, we're not going to run away from this mnemonic. We also use the same mnemonic, just that we're going to add something as we progress here. SOHCAHTOA. So let us see how we were doing it in secondary. We do a simple revision, how we were finding sin theta, cos theta, and tan theta. Okay, so for sin theta, so for sin theta, we were finding that it is opposite over adjacent. Rather, it is opposite over hypotenuse. Okay. So if we divide the opposite side by the hypotenuse side, we get what? The sine theta of the triangle. So just to find now theta, you just find the what? The inverse of that. Okay. So what of cos theta? So for cos theta is found by dividing adjacent side by hypotenuse. So if we divide this side and that side, we're going to get what? Cos theta. What of tan theta? So tan theta, we were saying that tan theta is found by, okay. So we are saying that tan theta is found by opposite over adjacent, like that. So now basically, now this is unit. So we're going to spice up something here. We're going to add to onga to this lesson so that at least it makes some sense and more enjoyable. At the same time, more educative and informative. Okay, so let us add something to that triangle so that at least now you start seeing the difference between uni and secondary year, because these are very common here: sin theta, cos theta, and tan theta. So let us now add something which is new. So let us try and put this same triangle that we were able to see there. Let us put it on a Cartesian plane. How is it going to be? How are the sides going to be affected? Okay, so if we put that triangle on a Cartesian plane, so this is a Cartesian plane, so that is a y-axis, and we have x-axis like that. Okay, so let us now put our triangle on this same Cartesian plane. So that is our right angle triangle. So this is y-axis and this is x-axis. Now we said before we had put this triangle on a Cartesian plane. That side we are calling it what? Adjacent. Now here it is going to be a little bit what? Different. So this same adjacent, as we can see, it is sitting on the what? On the x-axis. So we can represent the adjacent with x, just x. So adjacent now has changed from adjacent to what? To x. So we are going to term that side as what? X. And then this side, it's obvious it is what? Y, because it is along the y-axis. As you can see, it is vertically as well. Okay. So we are going to term that as y. And then this longest side, we are calling it hypotenuse. Now, after putting it on a Cartesian plane, so we can see that if we move from this point to this point, also from this point, same point, to this point, we are going to go to which? To this point here, which is the same as walking from this point to all the way to that point. So this is referred to as what? Resultant. So that is resultant. That side. We're going to term it as resultant. That is in physics, yeah. In physics, we call that as resultant. So even here, we're going to take it as a resultant. Okay, so now we have seen that the sides have changed from being hypotenuse to r, and from being opposite to y, and then from being adjacent to x. So meaning even the ratios have been affected. Where we are saying sine theta, where we're saying sine theta is equal to opposite over hypotenuse, it has changed now. There, where there's opposite, we're going to put y, and then where there's hypotenuse, we're going to put r. So let us do that. Okay, so now sine theta, okay, let me just put a triangle here so that we don't make any rough mistake. Okay, we have a triangle there, right angle triangle. We have this side is termed as what? R, this side x, this side y. So let us now find the ratios. So sine theta. So we know that sine theta will be equal to, so sine theta now will be equal to opposite over adjacent. So the opposite side there, it is y. And the hypotenuse side there, it is what? R. So this is now how the ratio of sine theta is going to be. So now let us try and make y the subject. Okay. So you need to pay attention. Pay attention and have the basics on these same common ratios. Because without the basics and the common ratios, even when we start looking at uncommon ratios, it will be very hard for you to understand. Yeah. At least pay very much attention. So sin theta, let us try and make y there the subject. So it is going to be y will be equal to r times sine theta. Okay, it is going to be r times sine theta. So if we multiply r with sine theta, we are basically going to have what? R sine theta. R sine theta. Okay, so this y is equal to r sine theta. Take note of it, r sine theta. So this one it is going to help us come up with a first identity of tan theta. Yeah, that one. Take note of that. Y is equal to r sine theta. So let us now find also for cos. We have seen that y is equal to r sine theta. So let us also now put it there. So for y, you will find that it is r sine theta. Okay. So we say y is equal to r sine theta, like that. Now let us find for cos. So cos theta will be equal to, we know that cos it is adjacent over hypotenuse. It is adjacent over hypotenuse, and then adjacent, it is the side which was here being represented by what? By x, and then the hypotenuse by r. So this one will be equal to now r over, or rather x over r. Where there is adjacent there, you put there that which is x. So you say x over r. Okay. So let us do that where we have said cos theta is equal to that. So cos theta will now be equal to x over r. So even here, let us do the same. Let us try and make x the subject. Let us make that variable our subject. So it is going to be x will be equal to r times cos theta. So if we multiply r cos theta, we are simply going to get x as r cos theta. So this is also what we are getting if we multiply r with cos theta. So it is, well, let us put it here as well. So x will be equal to r cos theta. Okay, so these two are going to help us find the identity of tan theta, the first identity of tan theta. So how do we maybe evaluate for tan? Because here we have seen that for cos we have found, and also for sine. Now let us try and evaluate for tan. So tan theta, the normal tan theta that we know, is opposite over adjacent. Over adjacent. Now we have put our triangle on a Cartesian plane, and these sides have been affected. Where there was opposite, we are now representing it with what? Y. And then for adjacent with x. So this one is going to be tan theta will be equal to y over x. So tan theta will now be equal to y over x like that. Where is y? It's obvious. We have seen. We can put the value of y there. And where is x? We can also put the value of x there, which is this r sin theta over r cos theta. Okay, so let us do that. So meaning our tan theta will now be equal to r sin theta. So r sin theta there over r cos theta there. Okay, so our tan theta will now be equal to r sin theta over r cos theta, because we said that tan theta is equal to y over x. We've just replaced there. Where there's x, we put what? The value of x. And where there's y, we put the value of y, which is sin theta, r sin theta. Okay, so here, this is just now basic mathematics here. We can see that this same r and this same r are the what? The same. So we can just cancel them. We divide them. R into r, it is 1. So we get tan theta. So tan theta will now basically be equal to sin theta over cos theta. Okay, so this is our first identity of tan. That is a must know. You have to know that tan theta is equal to sin theta over cos theta. Okay,